Let's think about liquids. Here's a simple activity from the chapter. Take 3 containers of different shapes. Label them A, B, and C. Fill container A with exactly 200 ml water. Pour that water into container B. The water takes the shape of container B, but the volume is still 200 milliliters. Now pour it into container C again. A different shape, the same volume. This tells us something important. The particles in liquids are free to move. Therefore, liquids take the shape of any container. But the particles are still so close together that the total volume remains the same. Therefore, liquids do not have a fixed shape, but they do have a definite volume. How do we know that the attractive forces in liquids are weaker than in solids? Try running your finger through water. Water gives way to your finger and springs back when you remove it. You can never do this with a solid. You can't put your finger inside a brick. In liquids, interparticle attractions are weak, so particles can slide past each other, but they're still strong enough to keep the particles together. Now, what happens when a liquid is heated? At a certain temperature, boiling point, particles gain so much energy that they completely escape the liquid and become vapor. This is the gaseous state. The boiling point of water, as you know, is at 100 degrees Celsius at atmospheric pressure. But here's an interesting point, and a student in the chapter actually raises this point. Congested water disappears even without heating it to 100 degrees Celsius. How? The answer is evaporation. Even below the boiling point, some particles near the surface of the liquid have enough energy to escape. It happens slowly. It happens only on the surface and at all temperatures, not just at 100 degrees Celsius. Boiling, on the other hand, happens throughout the liquid, not just on the surface. That's why you see bubbles forming. Evaporation happens calmly and gradually. Boiling is fast and violent,